Good morning or good afternoon. Now that you have an idea of how to write explicit and recursive functions, in this video we're just going to practice. So I'm going to give you questions before actually answering them, and then I'm going to model the answer for you. So make sure you have your notes nearby and take notes if you haven't already. Okay, so let's go ahead and get to this. We're going to first go with the explicit equation. I'm telling you these are quadratic, but let's go ahead and do the first and second difference. All right, there you are. So go ahead and do this yourself. There we go. Just going to make some extra rows in there. There you go. And it's going to look like a little Christmas tree. Early Christmas. So from 24 to 9, we're going down, so I'm subtracting 15. Then we start adding here. Okay. Second difference. Now we're going to find the difference here. Little baby Christmas tree again. So we're going from negative to less negative, so that means I'm going to be adding something. It looks like the difference is 8. And again here, 8 and 1 to 9, also 8. So just note, the second difference of a quadratic function will be constant, while the first difference is linear. Okay? So we're going to go ahead and start out with the explicit. Now I'm going to do the work right over here. Okay? So I'm going to do that little box again, just to keep me accountable of what my A, B, and C's are, plus the F of 1 that we need. So don't forget, A is the second difference divided by 2 when doing the explicit. Okay, so there's our second difference. Divide that by 2, giving us 4. We don't know what B is yet, but C is the y-intercept. So y-intercept, look where it's 0 for x, and just go over to the f of x column, which is 2. F of 1, wherever x is 1, there it is equal to 3. So remember, we have to solve for B using this magical little formula. F of 1 is equal to the sum of the A, B, C. Alright, I'm just going to go ahead and plug that in. F of 1 is 3. A is 4. We don't know yet. There you go. So I'm just going to add these constants here before I start transferring things over to the other side. 4 plus 2 is 6. So now I want to solve for B, so I have to get rid of this positive 6 by subtracting 6, giving me negative 3 for B. Okay? So remember, for the explicit, you have to use the standard form. Well, for now, which is, memorize this. This is the standard form of an explicit equation of a quadratic. Ax squared plus bx plus c. So now I'm going to replace my a with 4. There he is. Just move this right down. My b with a negative 3. So I'm not going to put a positive here. I'm going to go ahead and put a negative 3. And finally, plus 2. And voila, you have your equation there. But let's go ahead and check it. Make sure you check it. Hope I did it right because I don't want to redo this video. Let me just check some point. How about 1? That seems simple enough. So I have 4 times our x squared, which in this case is 1, minus 3 times 1 plus 2. So make sure you square the 1 first, which is just 1 again, times 4 is 4, minus 3 plus 2. 4 minus 3 is 1 plus 2. 4 minus 3 is 1 plus 2 is equal to 3. Let's see if f of 1, it matches. Woo! Did it. Congratulations. Hope you got that right. So this is the one you're looking for. Hopefully you gave me that one there. Okay, so that's for the explicit. Now I'm going to go ahead and do the recursive. Now it's time for you to do it. So now I'm going to go ahead and correct that for you. So for recursive, you could always just start it out the same. So I can already start giving the recursive. And some people call this the long one. Just, it's not longer. I guess written out maybe. And we're going to have f of x is equal to f of x minus 1. So now I'm going to go ahead and add or subtract something here. So remember, this one I don't really have to do much work. Actually, I don't have to do any work in this case. For recursive, the number in front of the x here is just going to be the second difference. You have to memorize that. Do not divide it by 2. That's not the case for recursive. So second difference is 8. There we go. X. And in this case, we are given -1 and 0. So this is going to be a little easier. We don't have to do any adjustments. Okay? So in your flip chart, it says that this part here is just the difference that you went from f of -1 to f of 0. So 9 to 2. How did you go from 9 to 2? Well, it's even shown there. To go from 9 to 2, you did -7. You could even do the math there yourself. And that's it. That is your recursive formula. Woo! All right, let's go to the next one. So I don't even have to do any work. Let's do this one, okay? So I'm going to give you some practice problems. So go ahead and try to do your second difference, your first difference, and go ahead and write the explicit equation. All right, so now I'm going to go ahead and quickly do this. So obviously we know these are quadratic, but make sure that you're getting a quadratic. There we go. So from 4 to 35, adding 31. If you need a calculator, do it. Get one. If you need to borrow one, I have some in the class. Okay, second difference. Well, that one was easy, right? Plus 20 all the way? Yeah, right? Okay. Little calculator needed there. Cha-ching. Okay, so for explicit. Again, I'm just going to make the little box. You don't have to do the little box. I do it to keep track. So I'm not looking all over the paper. A, again, explicit is the second difference divided by 2. In our case, 20 divided by 2 for 10. B, don't know yet for explicit, but C is the easy one. Oh, but wait, we don't have the 0. That means we're going to have to go backwards here a little bit, okay? So we're going to have to figure out what this first difference is so that we can figure out what this is. So we're going to go backwards. We know that we should have added 21 to whatever is there to get 31. So go ahead and go backwards. Instead of adding, let's subtract 20 from 31, giving us, dun, da, 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 then it just, what am I doing? 11. All right? Okay. So, again, let's pretend we had a little 0 there. So to get from the 0 term to this term here, we figured out that we had to have added 11 to this number to get 4. So we're going to go backwards now. Instead, we're going to subtract 11 from 4, giving us a magical number of 7, -7. Yeah, 4 minus 11 is -7. So now we have our 0, 0, -7. So you have to kind of figure this out here, how you're going to go backwards, okay? And our f of 1. That one's easy. Boop. And again, our magical little formula to help us find b. Plug it in. Okay. Recognize there's a negative there. So again, I'm going to combine these terms, the 10 and the -7. Subtracting from both sides, giving us b is equal to 1. Cool. So, the explicit. Start out with the f of x. I'm going to go ahead and write it so I always know what I'm supposed to get to. Alright, replace the a with the 10. Bring down my x squared. Plus my 1. Bring down my x. Plus, ooh, it's negative. -7. So hopefully you got this answer. And you get your points, yeah? I hope what you didn't get caught up in is this part, okay? So if you do think that you got this wrong and you want to redo it and everything, well, come in class and show me that you know how to do it, and I'll give you credit. As long as I know you know what to do, okay? Let's do the recursive now. Start it off the same. F of 1. You don't have to do 1. You can do 0 if you want. But I like f of 1. Always f of x equals f of x minus 1. Okay, so this guy, again, the term in front of the x is the second difference. Do not divide it by 2 for recursive. And now, this one, we don't have a negative 1. You can do the same thing we did here to find the 0 term and go back, but I'm going to show how we do the adjustment, okay, because we don't have a negative 1. So in this case, I'm just going to choose one. I'm going to choose f of 2. I like f of 2. And remember, what we're trying to find is the growth that was happening at f of 2. So the first difference, that should be what's in the row in the first, difference. There we go. So for 2, we're growing by 31, okay? But here, this is what we're growing by, right? 20x. In our case, the one we chose, our x is 2. So I multiply by 2. See what our growth is now. 40. So it's too much. At 2, we shouldn't be growing by 40. We should only be growing by 31. So let's make the adjustment. We should be growing by 31, so going to 40 to 31, we have to subtract 9. Bingo. That's the number that we're going to subtract so that this growth matches that growth in the first column. Okay? So this is just the explicit equation. Had you gone backwards here, you would have noticed that you would have had negative 1 and negative something. Really, really big negative. Okay? All right. So good job if you got it. Good luck next time if you didn't. Let's do this last example, and then you're done for this weekend. Here we go. Ooh. Yeah, baby. I'm just kidding, that was weird. Negative numbers. Don't be scared of them. They're okay. They're fine. So go ahead and see if you can do this yourself. Don't get too caught up with the negatives. Remember, a negative plus a negative is another negative, right? You're adding the negatives together, so how many total negatives? Okay, you only subtract when you have opposite numbers. Okay, let's see here. Let's try this guy out. Little Christmas tree. So negative 1 and negative 6. We're trying to get more negatives, so we have to add more negatives. Let's make it more negatives. And again here, we wanted to get more negative from negative 6 to get all the way to negative 17. And here, if you do the math, you'll see negative 17 plus negative 17 is 34. And then negative 23. Can you see that? There you go. So again, second difference. This is linear, not constant, so we must go on to the second difference to determine if it's quadratic. So negative 5 to negative 11, again, we're getting more negative. So we want to add negative 6. Negative 6, negative 6. All right, so it works out. Cool. So go ahead and see for the explicit. I'm going to do the table again quickly. A, what is that equal to? Question. Okay, so A is equal to the second difference divided by 2. Don't forget that negative divided by positive 2 is still negative. So we're going to have negative 3 for A. And then skip the B, go to C. That's our y-intercept. There it is. It was given to us. Thank you. You're welcome. So f of 1, negative 6. Okay. So again, we do the same thing. To find B, you must do our magical little equation to help us. So f of 1, and you have to use f of 1, don't use any other point. Okay? So f of 1 is negative 6, a is negative 3. Okay, so again, make sure you add these correctly. Negative 3 plus negative 1 is a total of negative 4. And since it's negative here, I'm not going to subtract, I'm going to add to both sides, because opposites cancel each other out. And negative 6 plus 4, I'm going to keep the negative because there's more negatives than positives, and it looks like there's 2 left over for the negatives. So our b is equal to negative 2. Whoa, everything's negative. It's possible. That's fine. So the explicit. Here we go. Quickly. Okay. I like to do that because I like to refer to it. So negative 3, yep, plop that little negative in there. Bring down the x squared. And instead of the plus here, since it's negative, I'm going to put the negative there. And then instead of the positive here again, I'm going to subtract 1. Alright, hopefully you got this. But again, check it. Check it all the time. Let me go ahead and show you how we're going to check that. I'm going to choose an easy one. The easiest one is 1 or 0, because squaring that's not going to do much for us, right? It's not going to do much damage. So we want to check f of 1 in our equation. So negative 3 times 1 squared. Only square the 1, not the negative 3. Minus 2 times 1 minus 1. Oops. So 1 squared is 1 times negative 3 is still negative 3. Minus 2 minus 1. These are all negatives, so add the negatives together, giving us a total of negative 6. Well, let's check it. Does 1 give us negative 6? Voila. It sure does. All right, so we got it right. Cha-ching. Recursive. Go ahead and try it. So recursive equation. Start off the same. Little f of 1 is equal to negative 6. F of x is equal to f of x minus 1. Uh-oh. So again, this guy is the coefficient. So if you want to add the plus here and then put parentheses, because you're going to have a negative, that's fine. You could also leave out this plus in parentheses and just put the negative in there. So we're going to have negative 6, and remember, this coefficient of x is going to be the second difference. Now to figure out what we're going to be adding, again, you can do this backwards, but with the negatives, it might be a little bit confusing. So you're going to do the method where you just do an adjustment, okay? So here's my little adjustment here. I'm going to choose an easy one. How about f of 1? Yeah? No, f of 2. I'm choosing f of 2 because, well, I don't know. I like f of 2. F of 2, the growth, let's look over. The growth, we were subtracting by negative 11 to get from 1 to 2. So that's our growth. Okay, so remember to do this as the growth for recursive here. Okay, so far our growth, given our little recursive thing, is negative 6x, whatever x is. We're using 2. So I'm going to go ahead and put negative 6 times 2 and see what we're getting so far. We're getting negative 12. And negative 12, well, we only wanted to subtract 11, not 12. So how are we going to do it to go to negative 11? So negative 12 to negative 11. Careful here. Do not subtract. If you subtract, you're adding another negative, making it 13. So we have to add 1. Adding 1 ends up subtracting a digit from the negatives, giving us less negatives. Okay? So, with that in mind, that's the number. Voila. Got a recursive. But I'm going to check it. Let's check it. On the test, you're going to have to check it. If you don't check, you're not getting your full points. So, let's check. There we go. Check for our recursive equation. So this part doesn't matter, right? Let's see. I'm going to check the point. Let's see. 3. F of 3 is equal to f of 3 minus 1 plus negative 6, well, our x is 3, so place that there, plus 1. So f of 3 is equal to f of, well, 3 minus 1 is 2, plus negative 18 plus 1. Okay, so what we're looking for f of 3 is negative 34. Let's hope. So f of 2, let's put in the value for f of 2 here to check it. Our value is negative 17. So negative 17 plus, well, I can go ahead and do this math here. Negative 18 plus 1 is negative 17, which, look, matches up with the growth that should be going on at that point, 3, at x equals 3. Matches up. Good. Our growth is right. So negative 17 plus negative gives us a total of negative 34. There you go. Yeah, hope you're getting this. And if you're not, it's okay. We're going to go over this again next week before the test. We're going to do a group quiz, and you're going to be fine as long as you pay attention, do your homework, do your work, stay on task. Okay, I'm over this. Let's go. Have a good weekend.